All right, so 13.4 talks about measures of variation. It's really preparing you for box and whisker plots, which are never my favorite thing. They're kind of useful for analyzing data. Some companies use them for analyzing data, but they never even had box and whiskers when I was your age. It's kind of a new analysis thing. And I mean, they are useful. They show how data is stretched out or packed together and that kind of thing. So we're going to find things today called the lower quartile, upper quartile, the interquartile range, and you already know how to find the median. All of these are just forms of medians. And I am going to start you on box and whiskers today so that when we do them on Monday, it's really the same lesson. We're just doing box and whiskers. We're also going to create stem and leaf plots today. And talk about all of these things within that. So I gave you this specifically so you could see these steps right here. Here's the steps that you're going to take to essentially start your box and whisker plots that you're going to do on Monday. The first thing that you're going to end up doing is you're going to find the median. In order to find the median, don't you have to put your data in order from smallest to largest? So on here, the data was already in order from smallest to largest. And how many pieces of data were there? Or are there? How many pieces? Yeah, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6. You're going to make a cut. You're going to cut that data in half because there is no one middle term. So then don't you have to find the median of those two numbers? Right? So how do you find the median of those two numbers? I'm trying to get that clear. Clear? Come on. There we go. All right. So add them together and divide by 2. What do you get? You do get 66, and that's how they came up with the 66. They added the 63 and the 69 together, and they divided by 2. So the median is equal to 66. That is the very center of the data. Then you take the lower half of the data, which is all right here. Since there is no middle term, the lower half has 6 pieces of data in it, doesn't it? Yeah. True? So then you're going to take that lower half, just like you would with a loaf of bread. Let's assume that we cut the loaf of bread in half. Now you have 2 halves. We're going to cut the lower half in half again. So don't I count 1, 2, 3 and make a cut right here? This gives you what's called the lower quartile. We've cut the data into quarters here. And then we have to find the median of those two numbers. Bless you. When it's the same number, what's the median? 31. And so this is called the LQ, lower quartile. You find it exactly the same way that you found the median. Then the upper quartile, because there isn't one piece of data, we include the 69 into the upper quartile. And so again, we have 6 pieces of data. You're going to cut this upper half in half, counting by 3s. So now we have 1, 2, 3, 4 quarters all together. You're going to find the median of these two numbers here. If you add 72 and 82 together and divide by 2, what do you get? 77. And this gives you the UQ, or the upper quartile. And then what's going to happen is, for your box and whisker, you're going to end up plotting the low piece of data, the high piece of data. You're going to plot the lower quartile, median, and the upper quartile as like a box. You're going to put a box around those numbers and put a line where that is. You extend something from here to here, and it looks like a box with little whiskers. But we're not going to do that part today. So this is all the preparation for your box and whisker. So then step 2, we did find the median of the lower half. This was, of course, our LQ. And then step 3, we found the median of the upper half. This was our UQ. And then the last thing that you have to do is find what's called the interquartile range. All you do is take the upper quartile, so this is the upper quartile, and you subtract from it the lower quartile. So upper quartile minus lower quartile equals the interquartile range, the IQR. And what this interquartile range does is it shows the width of the box in this box and whisker that you're going to make on Monday. All right, so I chose not to do these problems down here because you've got a bunch of homework to do, right? So let's look at that homework. So your homework says, for questions 1 through 4, create a stem and leaf plots. Now you've looked at several stem and leaf plots, right? Bless you. So one of the things today that we're going to do is talk about how to make a stem and leaf. So keep in mind this, because we're going to need it, because they're going to ask you some questions later on. For instance, look at what it says. After we create our stem and leaf, you're going to find the lower quartile, the median, the upper quartile, the range, and the interquartile range. So you already should know what the range is from the other day. But what's the first thing you think we should do? Yeah, I'm actually going to make a frequency distribution chart with tally marks, kind of like you would do for a histogram, because otherwise you have to put these in order from smallest to largest. It'd be a whole lot easier if you did it in terms of a frequency distribution chart, but we need to think in terms of our stem and our leaf. Do I have, for the most part, 1-digit or 2-digit numbers? Most of them are 2 digits, right? Let's identify our lowest number and our highest number. What's our lowest number? 3. So circle that. That's your L, your low number. And what's our highest number? 58, nothing higher than 58, right? So circle that. That's our high piece of data, H. So that means that I need to go from 3 to 58. So with stem and leaf, your stem versus your leaf. Your leaf is always, well, 9 times out of 10, we'll talk about the leaves down here on this piece of data down here, but 9 times out of 10, your leaf is always the ones digit. So your leaves are always one number. Your stem is the rest of the number. So if we had a 3-digit number, your stem would be 2 digits and your leaf would each be 1 digit. Since we have a 2-digit number, your leaf is going to be 1 digit, your stem is 1 digit, or your stem is 1 digit, your leaf is 1 digit, because the 1 digit is always just one number. So for example, if I'm going to cut 58, you're going to have a 5 for the stem, and then you're going to have an 8 for the leaf. Your leaves have to go in order from smallest to largest. So here's what I would start off with. So we're going to have our stem over here. If I have a 1-digit number and I know that most of them are 2, what technically is my tens digit for 3? 0. So I'm going to have a stem of 0, and it's going to go from lowest to highest, and I have to go up to 5. You don't want to include anything lower than this stem and nothing higher than this stem because you're not going to have any data in it. But if you're missing any data items in the stem from 0 to 5, you still have to include that missing piece, just not under it and above it. So we're going to go from 0 to 1, 2, 3, 4, and 5. So for right now, I'm going to split these up. And this is just my pre-stem and leaf. We have to put them in order. So start marking them off. 22, the 2 is going to go here, and I'm going to put a comma after each one of these. 14 goes under the 1 stem, so 4 goes here with a comma. 12 is also under the 1 stem, so I put a 2 with a comma. And so continue to put them where they belong in the right stem. I haven't gotten to it yet. I haven't gotten to it yet. Have I gotten to it yet? There's only 1 3. Right? And I have not done yet, so I'm getting that. Alright, so one of the things that you need to make sure that you do before you ever start your stem and leaf is once you've done this, now we've broken it up into 1s, 10s, 20s, 30s, 40s, and 50s, then make sure that you've accounted for all of the pieces of data here by counting all of this data. So I counted all of this data, there's 30, and I counted each of the leaves. I have 30 leaves. If your leaves do not check with the number of data, then your stem and leaf is going to be wrong and you don't want to continue doing it. So does everybody agree with where I put my leaves? Now, technically, and this is what you have to be really, really careful of, these should be done on graph paper so you can nicely even things out. So those of you who are sloppy students, you need to neaten yourself up. So if you need to do this on graph paper separately so that yours is nice and neat because that's the only way you can do it, then you need to do that. But for those of us who are neater, you can use your ruler and space things out evenly. So I'm going to make my final stem and leaf. You've got a vertical line, and you must label the columns with stem and leaf. If you leave off that label, you're going to lose points. So we have a stem, and we have leaf. So I'm going to start from top to bottom. So we're going to go 0, 1, 2, 3, 4, and 5. What's wrong? And so the only difference between this one and this one is this is my pre-stem and leaf. If I have a small number of data items, then I might not have to do this, but with 30, it's kind of hard to organize them while you're doing it at the same time. So then I'm going to take each of the leaves and I'm going to put them in order from smallest to largest. So my smallest leaf here is 3, so I've got a 3, comma. Then I've got an 8 and 2 9s. Then when you do your next stem, you want to make sure that you put these numbers directly below these other numbers. Don't squish them in because there's a reason why we have the stem and leaf. I'm going to show you when we're done with it, the purpose of it. Yes?
So you're saying that we don't need to do what we want
if you had a smaller set of data, like maybe if you're working with 10 numbers, you wouldn't have to probably do this. But if you've got 20 numbers or more, you're going to want to do a pre-one. The other thing you could do is just take these and put them in order from smallest to largest, but that's also kind of a pain. It's still kind of a pain. It's very easy to mess them up. Just saying. You could, but I'll be done before you will. Well, am I explaining things and instructing you while I'm doing it? Yes. Otherwise, I would have been done by now, too. Hopefully, you did it correctly. All right, so then I'm going to put these in order. So my smallest is 0. And then I have 3 2s. Keeping these each directly below the other. And then I have 1 2 3 4s. And then a 6. 8 and a 9. So if you squish yours together, it's going to look different than mine. Now the purpose of, in addition to this, we need to have a key. So you can choose any number that you want to make a key. So like you could choose the 3 and the 6, and your key would look like this. So you're telling the reader how to read your graph. If you miss the key, it's part of the points to this. So then if I turn this to the side, couldn't I kind of make a histogram out of that? You have a frequency here, right? And you can see the length of the bars. So a histogram can be turned into a stem and leaf, and the stem and leaf could be turned into a histogram. So they kind of go hand in hand. You can tell which stem has the most data items in it. We could go through a description talking about the range, the shape. I mean, what's the shape of this? Skewed to the left. And then if I have 30 data items and 10 of the data items are in the one stem, couldn't you say 1/3 of the data is in, and then what's the data related to? Executives reported telephone calls. So 1/3 of the executives reported telephone calls from 10 to 19 per week, right? Where only 2 executives made 40 to 49 phone calls in a week. So you can talk about the same thing that we did yesterday with your stem and leaves. But what are they asking us for this time? Lower quartile, median, upper quartile, range, and interquartile range. So we're going to find all of those. So 1, I would find my median first. So how many data items are there? 30. So I have to count 15. So I would start from the lower end, and you have to watch how you count. You can't count this way and then go backwards, can you? So you have to count 1, 2, 3, 4, then go back to the left. Count always from left to right. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Won't we cut the data right here? So I'm not going from 1 to 2 and getting 1.5. This is really 21 and 22. What number is in between 21 and 22? 21.5. So the median equals 21.5. Then I would find my lower quartile. So LQ is equal to. So how many pieces of data, because we don't have one middle piece, how many pieces of data are in the lower quartile? 15. Do you have one piece of data there? Yes, right? So if you take 15 and subtract 1 from it, you get 14. What's 14 divided by 2? 7. So count 1, 2, 3, 4, and go back to the left. 5, 6, 7, but that's not where I want to cut it. I'm not really cutting it. That's the middle piece of data, isn't it? There's 7 on the left, and there's 7 on the right. So this is your LQ. It's not 2, though. What is it? 12. And then we need to find our upper quartile. So you found your upper quartile by doing what we just did with the lower quartile. Do you agree the upper quartile is 33? Did you see how I got that? I counted 7. Left to right, 1, 2, 3, 4, 5, 6, 7, and then this next one is the middle number. All right, so what's left? So we need the range, right? Actually, I would do interquartile range next, because number 4, the interquartile range is equal to the upper quartile minus the lower quartile, right? So what's our upper minus our lower? 33 minus 12, which equals what? 21. And then last, our range. Your range, remember, is your high piece of data minus your low piece of data. So your high, we already said is 50. You can do the very outside one here with the very smaller one here. So 58 minus 3 is equal to what? 55. I'm not going to do this one with you, but I'm going to show you how to do your stem and leaf. So on this one, because this is different since it's money, so your stem versus your leaf, for this one, your cents are going to be your leaf. So like if you took $3.82, oh, interesting. What are they all? I'm going to backtrack on this one. What kind of dollars are they all? We don't want to have a three stem, do we? There's a $4, but there's only one, right? Okay. So instead, you are going to have your stems with 2 digits. Okay. What is your lowest dollar amount? 3.771. You don't see anything less than that, right? So there's our low. What's our high? 4.01. So you're going to have a stem that's, and I would actually write it as 3.7. I would. You don't have to, but I would. And then put the 1 over here, and then you'll have commas after it. So I'll get you started on your pre-one. Let's talk about the different stems that you would have. So here's your stem, and here's your leaf. So if our lowest is 3.7, and we have to go up to 4.0, won't you have 3.8, 3.9, 4.0, and then that's as far as you have to go, right? And then you'll have commas in between your cent, right? And so I'll let you finish that one. Let's look at another one. Wouldn't we hear you do the same thing? Wouldn't what's after the decimal point, which all of them only have 1 decimal place, wouldn't that be your leaf? And wouldn't your stem be what's to the left of the decimal point? That one wouldn't require you to use a decimal point, like we did on the previous one. Which would you like to do? 3 or 4? I think I'd rather do, you've got an idea of what to do, right? So I'd rather move on to number 6, because number 6 is a double stem and leaf. What's wrong? You okay? So look at number 6, because it's actually a double stem and leaf. A double stem and leaf compares 2 different things that deal with the same kind of topic. So it says, is there a difference in the ages of the Oscar winners who are best actors and best actresses? So we're going to have one side is going to be for women and one side is going to be for men. From 1996 to 2004, the ages of the best actors at the time of winning the award were, and they give the ages, and the ages of the best actresses at the time of winning for the same time period were, and they give those ages. So TJ, on here, would I need to do a pre-stem and leaf? No, because I have enough that I could organize those, right? You are to create a back-to-back stem and leaf plot for the actors and the actresses' ages, and then you have to comment on similarities and differences that can be observed. I'll let you comment on those on your own. We're going to go ahead and create it ourselves here. So what you're going to do is put the stem in the middle, and you're going to have leaves going out to the left and the right, and you kind of have to read them backwards. Remember the sandwiched inequalities that we had to read backwards? This is going to be the same thing. So your leaf, and then I would put on here that this would be women or actresses, and then this leaf would be men or actors. Now I know that it says here from 1996 to 2004. Does that have anything to do with our stem and leaf? No. So your ages. So let's look at, we have to find the smallest or the youngest and the oldest for both men and women together. So what's the youngest? So I see a 24. Is that the youngest?
Yeah.
Yeah. So 24 is the low piece of data. And then who's our oldest? I see 59, right?
59.
Anybody higher than 59? Did you notice, ladies, that who's the oldest? Men. Men can get away with being older in acting than women. or whatever. Men age distinguished. Men age better than women, apparently. All right, according to this. All right, so we have 24 to 59. That means we have to have a stem from 2 to 5, right? So we've got 2, 3, 4, and 5. So let's start with the women. We're going to go from smallest to largest on the right. So for the women, and don't forget these ones over here, our smallest or our youngest age is 24, right? So 4, try to be neat. And then 25, right? And then no more, 27. And then for our 30s, we have a 30. Oh, I don't want that. Why? Then we break into a new leaf or a new stem. Alright, so our 30 goes down here. And then we have 2 32s. And a 33. 34. So we had 9 women's ages and we have 9 leaves. So now you go to the men, but the men we have to go from smallest to largest, going from right to left. You have to go backwards. So for the men, our lowest data item is 28. So we do have a 28, right? So we have an 8. And our 30s, so women are younger. Doesn't that make sense? And then for your 30s, we've got a 35, a 36, so that's it, right? So 5, and then backwards is 6. And our 40s, we have 2 42s. And the 45 and the 40s, 2 45s. And then 46. And then 59. So then you're going to have to discuss, now that you've made that back to back, you're going to have to comment on the similarities and the differences. Let's throw some out here. What do you notice? Say that again? Yeah, there were, and this was for Oscar winners. So this is one thing that you might say. There were no female Oscar winners older than 39. And I would, because it says similarities and differences, so I would compare that to the men. Whereas the oldest male Oscar winner was 59, not 95, but 59 because we read it backwards. Oh, we have to have a key, by the way. So here's a key. I would do a key of the 30 stem or the 20 stem because you have one on each side. So let's just choose the 5, the 3, and the O. So 5/3/O is equal to 35 and 30. There's your key. What else do you note? There's lots of things we can talk about. That's just one thing. What else do you see?
There were more male women overall.
Not true. There were 9 men and 9 women. Yeah. So there's an equal number of male winners and female winners. So you could mention that. Now if you look at it this way, the women's graph is skewed which way? Highly skewed to the left, right? Whereas the men, if you turn it this way, if I had one more male over here, I mean, it is, okay, it is slightly skewed. Now, mind you, this is kind of backwards. It is slightly skewed towards the younger ages, right? However, there's quite a few men in their 40s that won, right? So the women, more women won in their 30s versus more men won in their 40s, didn't they? So that's something you can note as well. And then there's something else I was going to remember to tell you. Let's see if I can remember. It seemed like there was a correction somewhere. Yes, thank you. Number 5. So number 5, it says, what was the best score and what was the best score? Pretty sure I'm not asking you that twice. So this must be the worst. The worst test score. And then also on this one, I want you to change this to, yeah, how many students took the test. I want you to change this to how many students scored above 85. So make those 2 changes, and I think that will do it. Any other questions?